Okay, we'll be studying functions now. The time it takes for you to get, when you're traveling somewhere, the time it takes you to get to your destination is a function of how fast you travel. The faster you go, the shorter time it takes you to get there. The slower you go, the longer it takes you to get there. So how fast you go determines how quickly you get to a place. That's called a function. Okay? A function rule is an equation that describes the function. Here's some at the bottom. You're familiar with a function rule. It's just been called an equation before. It's a different vocabulary for you. At the bottom down here, you've got y equals 4x plus 4. That's a function rule. D equals 30t is a function rule. F equals 9/5 c plus 32 is a function rule. Function rules have input variables and output variables. Okay, so maybe you've been used to just having one variable. Now you're going to have two variables. Okay, but you're going to be given the information to be able to solve for the variable that you need. Okay, so the output variable is the y. The input variable is the x. The reason it's called that is because you put in a value for x. You work this out, and you get out a value for y. Over here, you put in a value for t, you work it out, and you get out a value for d. And the same thing over here. You put in a value for c, and you get out a value for f. So we have input variables and output variables. Okay, one begins his exercise walk from his friend's house, which is 50 meters from his own house. Let's look at this first before we move on. So here's, oh, that's beautiful. There's Juan's house. Okay, and then over here is his friend's house. Oh, his friend's roof is messed up. All right, but anyway, that's his friend's house. Can you read that? Of course you can. You're used to my writing already. So this is 50 meters. Okay, he starts here and he goes on a trip. Okay? So he begins his exercise walk from his friend's house, which is 50 meters from his own house. This function, d equals 3t plus 50, gives the distance that he is from his house after a certain amount of time. And we're measuring the time in seconds, and we're using t to represent time. D is going to represent the distance in meters that he is away from his home. So that means that every second he goes 3 meters. That's what this means right here. D equals 3t means D equals 3 meters per second, plus he was 50 meters already into his trip whenever he started. Okay? So we come over here, and all it wants you to do, find the output for the input t equals 10. If t is equal to 10, then you come over here and you put, instead of t, you put 10. And then you go 3 times 10 is 30, and 30 plus 50 is 80. And that tells us that after 10 seconds, he is 80 meters from home. And the cool thing about this equation, this function rule, is that it lets you find out how far away he is from home at any time. Okay, that's what the purpose of this function rule is. If he was 20 seconds into his trip, I could put 20 instead of t, and it would tell me how far away he is from home. If it was 100 seconds, then I could put 100 in here instead of t, and it would tell me how far away he is from home. That's the beauty and the use of a function rule. Now, an input-output table is useful to evaluate multiple values for a function. Also helps you organize data when the function represents a real-world situation. This is an input-output table. You have inputs of -2, -1, 0, 1, and 2. And when you put in -1 into the function rule, out comes negative 13. When you put in negative 1, out comes negative 12.5. And so on. So this is an input and output table. It's called that because you have the input side and the output side. Now let's look at how you get one. The function t equals 1/2 m minus 12 gives the temperature in a container in degrees Celsius minutes before, at the start, and during an experiment. So for example, let's say you take a beaker or some kind of container out of the refrigerator and you set it down, okay, and you're going to do an experiment. 2 minutes before you do the experiment, which is represented by the negative 2, 2 minutes before, you want to know what the temperature is. So you come over here and instead of m, you're going to put negative 2. And you go 1/2 times negative 2 gives you negative 1, and negative 1 minus 12 gives you negative 13. So you come over here and you put negative 13. Then we do the same thing for the negative 1. Instead of the m, we put negative 1, and we go 1/2 times negative 1 gives us negative 1/2, minus 12 gives us negative 12.5. And then we come over here and we put negative 12.5. And we do the same thing for the rest of the way. 1/2 times 0 minus 12 gives us negative 12. And we write negative 12. And 1/2 times 1 minus 12 gives us negative 11.5. And finally, 1/2 times 2 gives us 1, and 1 minus 12 gives us negative 11. And that's how you come up with an input-output table. Not too bad, is it? Alright, the deposit on a drink container is 10 cents in the state of Michigan. Use the function rule D equals 0.1 C. 0.1 is the same as 0.10. It's just you don't need the 0 in the formula, in the function rule. Make a table of input-output pairs to show the total deposits on 5, 10, and 15 containers. So we've got D equals 0.1 C. And we're going to have input and output. Okay, we want to know the input for 5, 10, and 15. So we come over here and we go D equals 0.1 times 5, and that gives us 0.5. So we put 0.5 over here. And since it's dollars and cents, we put that 0 on the end there. And then we go D equals 0.1 times 10, and that gives us 1. And then we come over here and we put 1.00 because once again it's dollars and cents, and that's how it's written in the United States. Okay, so then we go D equals 0.1 times 15, and that equals 1.5, and we'll write 1.50. And that's our input-output table for that function rule. Alright, I'm giving you a function rule of z equals 2x plus 3. And what you need to do is find each output. Now, sometimes these things seem a little bit more complicated than they are. But all it wants you to do is take z, and you put the 2, and instead of x, you're going to put 0. And then finish writing the function rule, and that will be z. I should put that there, shouldn't I? Equals 2 times 0 is 0 plus 3, z equals 3. All right, you do the last two and see if you get the same answer that I will show you whenever I come back to you. Pause the video and do these last two. Okay, let's see. We've got z equals, and we put 2 times negative 2 plus 3 gives us z equals negative 4 plus 3, which gives us z equals negative 1. Did you get that? Okay, good job. All right, z equals 2 times negative 16.7 plus 3. That gives us z equals negative 33.4 plus 3, which gives us z equals negative 30.4. Okay, good job. All right, the function rule E equals 0.4H gives the total energy E in kilowatts that a stereo uses during H hours. How much energy is used during 3 hours? Once again, all it wants you to do is take the value that I give you for H and put it in where you see H in the function rule. So this will be E equals 0.4 times 3, which gives you E equals 1.2. So that's the amount of energy that it would use in 3 hours. Okay, it says copy and complete a table, but we're not going to copy it. It's right here. Complete the table of input-output pairs for the function rule T equals N over 11. The variable T represents the number of teams formed in a hockey league, and the variable N represents the number of people signed up. So based upon the number of people, there are 11 people on a hockey team. Based upon the number of people, it will determine how many teams that we have. So we come over here and we go T equals. And instead of N, we're going to put 44. So it would be 44 over 11, which would be 4. And so we come over here and we put 4. Okay, then we go T equals 132 over 11. And that gives us 12. So we put 12 here. And then it gives us T equals 165 divided by 11, which gives us 15. You see? You getting this?